Hello, I am James, in reference to Dr. Burns at Pstcc State. I will be discussing and demonstrating limiting reaction problems step by step. What is limiting reaction? Whenever you perform a chemical reaction with two or more chemicals, one chemical is going to hold you back. So let's take this practical example. It has nothing to do with chemistry. 4 tires plus 4 headlamps still equals 1 car. We have enough headlamps for 2 cars, but you only have enough tires for 1 car. You can't have 1 car with no tires, so you may as well just do 4 tires and 2 headlamps, which would give you 1 car as well. The other one, you would just have 2 headlamps left over. Now for a chemistry example. Here we have ammonia reacting with chlorine gas to give us nitrogen gas, resulting in NH4Cl. The coefficients are 8 for NH3, 3 for Cl2, and then 1 for nitrogen gas and 6 for NH4Cl. The molar mass for NH3 is 17.03 AMUs. The molar mass for chlorine gas is 70.90 AMUs. And the nitrogen gas, which we actually won't use in the problem, is 28.01 AMUs. And then NH4Cl is 53.49 AMUs. Our goal is to figure out which is limiting this reaction, NH3 or chlorine gas, and how much NH4Cl we will receive. In our problem, we have 277.70 grams of NH3 and 439.5 grams of chlorine gas. All I have to do is set the problem up and do stoichiometry twice, and whatever gives you the lower result is your limiting reaction. So we're going in the first step, we're going to assume that chlorine gas is abundant and that NH3 is the only limit. So I put 277.70 grams of NH3 over 1. And I have 1 mole of NH3 over 17.03 grams of NH3 because that's the molar mass of NH3. We're simply converting from grams of NH3 to moles of NH3. Now we have to figure out the ratio of NH4Cl to NH3. So it requires 8 NH3 to yield 6 parts of NH4Cl. So it's a 6-to-8 ratio. Now, since it requires 8 parts of this to result in 6 parts of this, it's 6 out of 8 instead of 8 out of 6. Very important. This gives us the amount of moles of NH4Cl. All I have to do is convert to grams. And you put 53.49 grams of NH4Cl over 1 mole of NH4Cl. And our answer with 4 significant figures is 656.2 grams of NH4Cl. Alright. We are not done yet. This is just if NH3 was our limiting reaction. We don't know that yet. So we do it twice, this time assuming NH3 is abundant. We have 439.58 grams of chlorine gas. Let's put that over 1. Now we have to convert to moles. One mole of Cl2 gives 70.90 grams of chlorine gas. Now let's create a ratio. It requires 6 parts of NH4Cl, requires 3 parts of chlorine gas. So that's 6 out of 3. And since there's a smaller coefficient in front of chlorine gas and a larger one in front of NH4Cl, the ratio is 6 out of 3. Okay, now we convert to grams of NH4Cl. So we have 53.49 grams of NH4Cl, and we put that over 1. If you type all this into your calculator, you'll receive, with 4 significant figures, 663.3 grams of NH4Cl. Now we have completed the problem twice. The answer is 656.2. The reason is you always select the lower number. The reason is we're assuming the other one's abundant. You're going to have one that isn't abundant. In this one, we'd have to be creating NH3. In this one, we're just not reacting with all the chlorine. You can't create, but you can just not react with. And our answer is 656.2 grams of NH4Cl. NH3 is the limiting reactant. All right. And a final example. We have C6H12O6 reacting with 6 parts of O2, resulting in 6 parts of carbon dioxide and 6 parts of water. Before we even consider the problem, we're seeing which one is limiting, glucose or oxygen, and how much H2O we'll receive at the end. We can go ahead and write out all the molar masses. We have 18.0, 180.0.1, and 32.00 AMUs of oxygen, and the molar mass of carbon dioxide is 44.01, and the AMUs of water is 18.02. Now we look at the problem. We have 237.8 grams of glucose and 240.87 grams of oxygen. So let's do stoichiometry twice and see which one is limiting. We have 273.81 grams of glucose. Let's put that over 1. Alright, now we just have to convert to moles of glucose. So we put 1 mole of C6H12O6 and put that over 180.16 grams of glucose. This will give us the amount of moles of glucose we have. Now I have to figure out the ratio. We realize that there are 6 parts of oxygen yielded for every 1 part of glucose. So it means the fraction must be larger since it requires less amount of glucose to result in more amount of oxygen. So the ratio is 6 to 1. Okay, now this will give us the amount of moles of H2O. All we have to do is convert to grams. I have 18.02 grams of H2O over 1 mole of H2O. This will give our answer of 142.7 grams of water with 4 significant figures. We're not done yet. We do this one final time. This time assuming that glucose is unlimited. So I have 240.87 grams of O2 over 1. And I'm going to convert to moles. So 1 mole of O2 over 32.00 grams of O2. Now we figure out, this will give us the amount of moles of water. Well, I'm sorry, not yet. We have to figure out the ratio of oxygen to water. Both of them have the same coefficient, 6 and 6. So the ratio is 6 out of 6. This will give us the amount of moles of H2O. Now we convert moles of H2O to grams of H2O. We do 18.02 grams of H2O and put that over 1 mole of H2O. This will give a final answer of 137.0 grams of H2O. 137 and 142.7. 137.0 is smaller. So oxygen is limiting at 137 grams of H2O is your solution. Thank you.